This is Precalculus section 1.2, day 3 notes. Today we're going to continue talking about rational exponents. For any rational exponent m over n in lowest terms, where m and n are integers and n is greater than 0, the definition of a rational exponent looks like this. We have a base a and we have a power m over n. Okay, now keep in mind that it's actually the m part that is the power, and it is the n part of the exponent that is the root. So we could rewrite this expression in radical form, and it would be the nth root of a to the mth power. Okay, we could also say that a to the m over n is equal to the nth root of a to the mth power. So we can tuck that exponent inside underneath the radical, or we can leave it outside the radical. Okay, so these are both correct ways to write this. So now for our examples, we're supposed to simplify the expression and eliminate any negative exponents, assuming all letters denote positive numbers. So basically that's just so that we're keeping things real here. So 125 to the 1/3 power, if we change that to radical form, remember the exponent is 1 and the root is 3. So this is really the cube root of 125 to the first power, or just the cube root of 125, which we know is 5. Number 2, 4 to the 3/2 power. Okay, so option 1, we could tuck the exponent under the radical. So our root is 2. It's a square root of 4 cubed. We can simplify 4 cubed. That's 64. And then the square root of 64 is 8. Okay, but we could also look at it as the square root of 4 to the 3rd power and put that exponent on the outside. But as you're going to see, we're going to get the same answer, because the square root of 4 inside the parentheses is 2, and then 2 cubed gives us an answer of 8. So either way you do it, it's just basically doing exponent rules in a different order, you get the same answer. Number 3, we have that 1/4 exponent outside the parentheses, so we have to distribute that to both bases. So we're going to have m to the 4th power to the 1/4 power, and we're going to have n to the negative 3rd power to the 1/4 power. So in both cases, we have a power to a power. We're going to multiply our exponents. When we multiply 4 times 1/4, this just gives us m to the 1st. And here we have n to the negative 3/4. Okay, now we know from our exponent rules that we're going to need to bring that downstairs. So we're still going to have our m to the 1st upstairs, but then downstairs we're going to have n to the 3/4 power. Now we're going to need to rationalize that. Okay, so again, because a 3/4 power is a radical in the denominator. So if we want to rationalize that, we want to make our exponent a whole number. We already have 3/4, so it would be ideal if we could make that denominator n to the 4/4 power. So in order to do that, we're going to rationalize by multiplying by n to the 1/4 power, because 3/4 plus 1/4 would give us 4/4, right? Which would just give us n to the 1st. So when we do that, again, I'm going to label this RTD for rationalizing the denominator. We're still going to have that m to the 1st power on the top, and now we're going to have n to the 1/4 power that we introduced. But in our denominator, we're going to have n to the 4/4 power, which is just n to the 1st. So final answer is going to be m times n to the 1/4 power over n. We could also write that as a radical. So that would be m times the 4th root of n over n. And either one of these would be correct notation. Example number 4, I'm going to start by distributing that 1/4 and distributing that 1/3. So when I multiply 8 times 1/4, that's basically 8 divided by 4. So that's going to give me x squared. And then y to the -4th to the 1/4 is going to end up giving me y to the -1. On the bottom, I'm going to distribute my 1/3. So that's going to give me x to the -2/3, and then y cubed to the 1/3 power. 3 times 1/3 is just going to give me y to the 1st. Okay, so now I've got a couple of negative exponents here. So I think I'm going to start by moving anything that has a negative exponent either up or down. So this is going to be my next move. Okay. So now that x squared upstairs stays right where it's at, but that x to the 2/3 power is going to come up. And then I've got that y to the 1st downstairs, but now I'm bringing down that y to the -1, and that's going to become y to the 1st as well. Okay? So now, to simplify this a little bit, I can either write this as x squared, and then I can leave this as x to the 2/3. That's one option. Okay? And then I can write this as y squared on the bottom. Or I can write this as x squared and then the cube root of x squared with y squared on the bottom. Okay. So either of these would be correct notation. Now we're going to change gears a little bit. We're going to talk about scientific notation. This is something that you've seen many times before, both in math classes and in science classes. A positive number has the form x equals c times 10 to the nth power, where c is between 1, or could be 1, greater than 1, but must be less than 10. And n is an integer. So for our first example, if we want to write this number in scientific notation, we need to move our decimal point so that the number that we're starting with is somewhere between 1 and 10, greater than or equal to 1, but less than 10, which means that we're going to have to move that decimal point to between the 4 and the 5. So I'm going to write 4.5643 times 10. Now I have to count how many places I moved it. I moved it 1, 2, 3, 4, 5 places. Okay, since I moved it 5 places, now keep in mind this is a very small number. Small numbers are going to have negative exponents. So let's make a little note here. Small numbers, which when we talk scientific notation, are numbers less than 1, have negative exponents. In scientific notation. Okay? For example number 2, we're given a number that's already in scientific notation, and they want us to rewrite it back in decimal notation. So the first thing I notice here is the exponent is positive, which means that this is a big number, right? So we're going to make our little note here. Big numbers, which are greater than 1, have positive exponents in scientific notation. Okay. So we know that this is a big number. So if we're going to move our decimal point 5 places, we want to make this number look bigger, not smaller. So we're going to be moving it 5 places to the right. So we've got 7, 9, 4. So if we put it past the 4, we've moved it 2 places. We need to move it 3 more. So we need to add 3 more zeros. So this is going to end up being 794,000. Our last examples here want us to work with numbers in scientific notation and do some computations. So it says, use scientific notation, the law of exponents, and a calculator to perform the indicated operation. State your answer correct to the number of significant digits indicated by the given data. Okay, so first of all, when we look at these two numbers, the first number that we're multiplying has 3 significant figures, and the second number that we're multiplying has 4. We can only be as specific as our least specific numbers. So we're limited to 3 significant figures in our answer for this one. So I'm going to write that down so that when we get to that point later and we do some rounding, we know that we can only have 3 sig figs in our answer. All right, so we're going to kind of break this problem apart into 2 pieces. We're going to multiply the base numbers together, 6.31 and 2.345. And then we're going to multiply the powers, 10 to the negative 4th times 10 to the negative 7. Okay, so we grab our calculator, and this part on the calculator gives us 14.79695. Okay, we use our exponent rules, multiplying powers with the same base, we add our exponents, so this is going to become 10 to the negative 11th. Now the problem with this answer is, number 1, it's not in correct scientific notation. Number 2, it doesn't have the correct number of significant figures. So first, let's fix the scientific notation. Right now I've got 14 point something. I need this to become 1.479695. Now, I had times 10 to the negative 11th. That was a small number, right? And small numbers, the decimal point gets moved to the right. Well, to fix it, I move my decimal point 1 place to the left, which means that this is going to become a negative 10. Last thing here, I can only have 3 significant figures, so I'm going to round my answer so that it's correct, and it's going to be 1.48 times 10 to the negative 10th. Okay. Last problem here, I'm going to do in a very similar way. And if I look at all these numbers, once again, I'm only going to be able to have 3 significant figures in my answer. So I am going to first write everything in scientific notation. This number right here is really 9.837 times 10 to the negative 4th, because I moved that decimal point 4 places to the right. And this one is going to be 9.88 times 10 to the negative 3rd. Okay, now that everything's in scientific notation, it's going to be a lot easier to work with. So now I can just grab my calculator. I can multiply 9.837 times 3.65 divided by 9.88. And then over here, I can do my work with my tens. So this is going to be 10 to the negative 4th times 10 to the positive 6th divided by 10 to the negative 3rd. Okay. So grab my calculator here. And the left side, when I multiply and divide, I end up with 3.6341 times 10 to the, okay, let's do the numerators. Negative 4 plus 6 gives me 2, and then 10 to the 2nd over 10 to the negative 3rd. When I bring that negative 3 upstairs, combine it with the 10 to the 2nd, this becomes 10 to the positive 5th. Okay, I have to simplify to correct significant figures, so I have to round. This is going to end up being 3.63 times 10 to the 5th power for my final answer.